Hello everyone, my name is Monish Gowda, studying history in Ventishwara College of Engineering. Here we discuss about Newton's forward and backward interpolation. Introduction to Newton's forward and backward interpolation. Newton's forward and backward interpolation are numerical methods used for approximating values of a function between known and known data points. These methods are based on the principles of polynomial interpolation, which involves fitting a polynomial curve to a set of data points. Newton's interpolation techniques are widely used in various fields such as engineering, physics, and computer science. Newton's forward interpolation is used to estimate the value of a function at a point beyond the last known data point. It uses a forward difference table to calculate the coefficient of the interpolating polynomial. The forward difference table is constructed by taking the difference of consecutive data points in the given dataset. Newton's forward interpolation. The Newton interpolating polynomial is given by the formula p of x is equal to f of x naught plus x minus x naught into f of x naught comma x1 plus x minus x naught into x minus x1 into f of x naught comma x1 comma x2 plus so on, where f of x naught comma x1 denotes the forward difference of order 1 and f of x naught comma x1 comma x2 denotes the forward difference of order 2 and so on. The values of the function at a desired point can be calculated using the interpolating polynomial. Newton's backward interpolation. Newton's backward interpolation is used to estimate the value of a function at a point preceding the first known data point. Similar to forward interpolation, backward interpolation also uses a backward difference table to calculate the coefficient of the interpolating polynomial. The backward difference table is constructed by taking the differences of consecutive data points in a reserve order. The interpolating polynomial of backward interpolation is given by the formula p of x is equal to f of xn plus x minus xn into f of xn comma xn minus 1 plus x minus xn into x minus xn minus 1 into f of xn comma xn minus 1 comma xn minus 2 plus so on, where f of xn comma xn minus 1 denotes the backward difference of order 1 and f of xn comma xn minus 1 comma xn minus 2 denotes the backward difference of order 2 and so on. By using the interpolating polynomial, the values of the function at a desired point can be approximated. Advantages of Newton's forward and backward interpolation. Newton's interpolation methods are relatively simple to implement and understand. This technique can provide accurate approximations of the function values within the given data range. Newton's interpolating methods can be used for both evenly and unevenly spaced data points. Limitations of Newton's forward and backward interpolation. Newton's interpolation techniques can become computationally expensive for large datasets due to the need to form difference tables. These methods assume that the function being interpolated is well behaved and be accurately represented by a polynomial. Extrapolation using Newton's interpolation methods can produce unreliable results outside the range of known data points. Applications of Newton's forward and backward interpolation. Newton's interpolation methods are commonly used in numerical analysis to solve problems involving interpolation and approximation. These techniques find applications in fields such as physics, engineering, finance, computers, graphics, and data analysis. Newton's interpolation methods are particularly useful in situations where regular sampling of data is not possible or practical. Example Newton's forward interpolation. Let's consider an example. We have a set of data points x, f of x as follows. Using Newton's forward interpolation, we can estimate the value of 2.5 by constructing the forward difference table and applying the interpolation polynomial formula. We can find the approximation. Let us use the same set of data points as in the previous example. This time we want to estimate the value of f of minus 0.5 using backward interpolation. By constructing the backward difference table and applying the interpolating for polynomial formula, we can find the approximation. Comparison of Newton's forward and backward interpolation. Newton's forward interpolation is used when estimating values beyond the last known data point, while backward interpolation is used for values preceding the first known data point. Both methods construct difference table but in different directions. The choice between forward and backward interpolating depends on the direction of approximation needed. Summary of Newton's forward and backward interpolation. Newton's forward and backward interpolation are numerical methods used for approximating values of a function between known data points. These techniques involve constructing difference tables and using interpolating polynomial to estimate function values. Forward interpolation is used for values beyond the last known data point, while backward interpolation is used for values preceding the first known data points. Reference: Burden,